All right, guys, last thing that we talked about were your tolerance and population. This is going to go a little bit more into that. It's also going to talk about your links and hair worksheet that you should be getting in. You should have got it maybe yesterday or sometime before next Wednesday for sure. But I do want to hit a couple things. The tolerance one that I had sent out there is for you to look at. And to look at how populations interact, we got to know those patterns. We got to know how they are found around the world. We talked about those in terms of geographical barriers, physical factors, just different kinds of species living in those habitats or niches. And then how their distribution occurs. We got three different forms of that is right there in your notes: uniform, random, and clumped. And one of the worksheets that you just got yesterday is going to deal with that. And we're going to find out that clumping is the most common form of population distribution, because resources are not going to be uniform. Okay, there's never a resource that's uniform, no matter what that is, whether it's water or food or other members of that population, of that species. So make sure you review that in your notes. I'm not going to really hit that. I think it does a really good job just defining those for you. And then we have constraints on population. I gave you a little statistical equation there for the change in numbers is births plus immigration, things moving into a system, minus the deaths and emigrations, things moving out of that population. And that's definitely going to give you numbers, which leads to our survivorship curves, which have to deal with the kinds of critters that we deal with in populations, depending upon what they are. So in your notes, you have a curve that has the percent surviving right here. Sorry, I don't know, I wrote 100 there, but that needs to be on the top. This is your 100%. This is at birth, okay? And this is our percent surviving. Okay? Down here are our numbers. Okay? Over time. And this is a big deal. And you had three types. We had early loss, late loss, and constant loss. Okay? Late loss is when we look at something where at birth, we have lots and lots. Everybody lives for a long time. But then our numbers drop off at the end as we get to old age. As you see on the lab or on the notes, this is humans and elephants. We follow a late loss curve. Other organisms that we're pretty familiar with have a constant loss. Means that they have 3 or 4 eggs like a bird, and only sometimes all 4 make it, sometimes only 3 make it. And they have a constant loss. So they have a nice straight line. And then we have other species that produce lots and lots of offspring. Things like frogs, fish, insects produce thousands and thousands of eggs, but the great majority of them die, and very few of them make it to an older age. So we have late loss, constant loss, and early loss. And you have to apply that to populations that you're going to be dealing with. And again, that comes in with the predator-prey worksheet that we'll be looking at here in just a second. One other thing that I wanted to hit from our population notes were 2 curves that have been in the news a lot. And I said that we were going to talk about them. And that is the exponential curve and the logistical curve. Exponential growth, and we are going to talk about logistic growth really quick. Again, I told you in this class there's lots of breeding graphs. Again, on the bottom on our x-axis are going to be numbers. On our y-axis is going to be sorry, I got that backwards. I'm going to go too quick here. Up here is going to be our numbers of organisms. And down here is going to be time. Just time. So, we kept hearing about this coronavirus thing and talking about stopping the exponential growth. In exponential growth, we see what's called a J curve. Okay? This is when there's unlimited resources and that population can take off. It looks like the letter J. This is called a J curve. You'll hear that quite a bit. Okay? Now, when J curves happen, this happens a lot with viruses, bacteria, and stuff like that. They will take off. They will destroy basically their food sources, and then they crash. Okay? And that's what we normally see in those kinds of populations. Okay? So what they were talking about with this virus and social distancing and stuff is they were trying to turn this J curve into what we call an S curve, which is flattening that out and trying to get it to what we call in ecology a carrying capacity. So, yes, we have that initial number, starts off low, then they start to grow, but then it gets up to here and it starts to level off. Okay? Now, in a population, we call this, when it hits this line right here, we call this carrying capacity. Okay? Carrying capacity. And that's where the environment is it's most stable. Okay? So we get up here and we flatten the line out. We're not having this exponential growth where something is taking off and taking out the entire environment. We hit this little curve here. Now, something that I do need to show here is that on a lot of these curves, and when we draw them, we always show this as being a flat line. Okay? It's really not a flat line. And this is what you're doing with the, again, links and hair worksheet, which we're going to get to here in a moment. So let's keep the S curve here. But when this actually gets up here, this is actually a wavy line. And those of you that are in your math classes might remember that. It looks like a sine wave. Okay? And this is just telling us relationships within those populations are not always equal because resources are not equal all the time. So sometimes there's a lot of food, sometimes there's not a lot of food. Sometimes there's a lot of prey items, sometimes there's not a lot of predators. All these things are going to give us, which then if we put in our dotted line here, it looks nice and flat, which is what most people look at. Hey, that's an S curve. It looks like a letter S. It's actually kind of wavy. Okay, I want to make sure I reiterate that. And this is what we're focusing on when we talk about competition. That's that second set of notes that I sent to you guys on competition. Okay. Let me drag those up. This was on interactions with communities. And the main part of this, and I even mentioned it in the last video, is I want you to look at the competition part of the notes, where we're talking about intraspecific and interspecific competition. Intra is within the species, competing for mates and even food and things like that. And then you got interspecific, which is between different species, which may compete for the same resources. And competition is the biggest controller of populations. Okay? One of the things we already talked about is that we know that organisms don't all occupy the same spot because the competition would be too high. And in nature, you're either dead or alive. There's no middle ground in there, okay? So organisms fit into different habitats. They fill a niche within that habitat, and they try to stay as away from each other as much as they possibly can, believe it or not. So what this leads to is these competitive processes that we want to look at, okay? And you'll read through a couple of those. Exploitation competition, interference competition. I'm just going to read through a couple that are on my notes that you guys have. Competition can limit other species and to allow coexistence. This is resource partitioning, separating themselves out into those niches and habitats so they're not competing all the time. Character displacement. What kind of behaviors do they have? Coevolution between organisms. We talked a little bit about like bees, wasps, and flowers and how they can interact with each other. So this leads us to predator and prey. So on that competition of communities, or the ecology of communities, I definitely want you looking at predator-prey relationships. And if we had regular class, we would definitely be doing a lot more with this, with some more videos and talking about the introduction of the wolf, but we're just not going to get to that this year. I'm still trying to figure out how I can get that in there. So we may get that in there sometime. So I want you to definitely read through that. And then you're going to get into predator-prey relationships and how these strategies are going to either give that organism a benefit to make it through that situation, or if they are going to lose out to a better fit organism. So some of those things that we talk about in there, we got predation, how populations of predators and prey interact. You know, can they hide? Do they have certain techniques to get away from each other? Do they have defense systems? You know, things like that. You'll read about integrated pest management in there on how we introduce species and how we use species to control other species. We hear about that all the time. If we take out all of the prairie dogs, then all of a sudden, you know, the coyotes are going after game or after livestock and things like that. Okay, because they have nothing to eat. Okay? Then we see a loss of predators too down the line, and that's what you should be seeing in this worksheet that you got. So here's the worksheet. Okay, your predator prey. You had to read about the lynx and the hare. This is a case study actually based on trapping information out of Canada. So you read through this a little article, and then you had to fill in this data table. You had your years and you had your numbers, and there should be 2 different lines on here showing me the snowshoe hare, and they should be showing me the lynx, the cat, and I should see 2 of those. I should also see a number of different things written on your graph. Now, you had some answers that go along with that. You had to answer those questions. I'm just going to flip through them, and I am going to show you what your graph should look like. Okay, now this is not the complete graph, but this is what you should have come up with. Something very similar to this. I'm going to look for, did you write in the things that it asked you to write in on your graph? Okay, so make sure you take a picture of that and send it to me. That lets me know that, hey, you read through it. You read through your notes on predator-prey relationships, and you can see this kind of lagging between the prey and then you have the predator. So the peaks are never at the same time. Those are important things. Okay, so here's what it's going to look like. Check your notes, check your emails, keep working on your assignments, and I'll talk to you later.